So this is the question asked in GATE 2019 Electronics and Communication Engineering paper, in which you have given h of n as a length 7 discrete time finite impulse response filter whose values are given from -3 to +3, and hn is 0 for mod of n greater than equal to 4, which implies that when n less than -4 and n greater than 4, this h of n is 0. So this h of n is live from only -3 to +3. Also, you have given a g of n, which is a length 3 approximation of this h of n, such that this condition, that e of h of g, which is given as -pi to pi, and magnitude of h of e j omega minus g j omega square, is minimum, where these h of e j omega and g of e j omega are the discrete Fourier transform of h of n and g of n. So for this minimization, that e of h of g, you need to find out the value of this 10 g of -1 plus g of n, g of 1. So the NPTEL reference for this question is Discrete Time Signal Processing by Professor Mrityunjay Chakrabarty. So the useful data for this question is that you should know the Parseval's theorem. Parseval's theorem, which states that the energy contained in x of n, that is from n equal to -infinity to infinity, magnitude of x of n square, will be given by 1 by 2 pi integration from -pi to pi magnitude of x of e to the power j omega whole square d of omega. So this is the useful data for this question, that you should know that you can write energy of a signal in terms of Fourier transform, the discrete time Fourier transform also. So in the given question, you have given h of 0 equal to 4, h of 1 as 3, and h of 2 as 2, h of 3 as 1, and h of -1 as -3, and h of -2 as -2, and h of -3 as -1. Or you can write this one as h of n as -1, -2, -3, 4, 3, 2, 1, and this is your 0 point, n equal to 0, and this is your n equal to -3, and this is equal to n equal to +3. Now you have given g of n, which is length 3, and this is a approximation of h of n. Okay. Also, you have given this condition e of h of g as -pi to pi magnitude of h of e j omega minus z of e j omega whole square d omega. This should be minimized. So then g of n, whatever g of n value or should minimize this, that is your value of g of n. So from Parseval's equation, you can write this one as -pi to pi h of e j omega minus z of e j omega whole square d of omega equal to 2 pi summation n equal to -3 to 3 h of n minus g of n whole square, and this is equal to E of h of g. From Parseval's equation, you can write this one as this equation. So you can see that if it is minimum, then this factor should also be minimum, and this factor should also be minimum. So if you can minimize this summation, that is n equal to minus 3 to 3 h of n minus g of n whole square, if it is minimum, then your E of h of g will be minimum. So if you can see that your h of n is given by minus 1, minus 2, minus 3, 4, 3, 3, 2, 1. So you need to subtract g of n from this such that this value should be minimum. So if you can subtract, that has highest strength, that is, if you can see that highest strength is minus 3, minus 4 and 3. So if you can subtract these three values, then h of n minus g of n will be small. So this h of n minus g of n is small. So magnitude of h of n minus g of n square will be also small. So if you can subtract the highest values, whichever has highest value from h of n, then this h of n minus g of n will be small. So if you can select g of n as minus 3, 4, 3, that is length 3, and also this minus 3 and 4 and 3 will subtract from this h of n will give you minimum E of h of g. So now you have g of n as minus 3, 4, 3. So you need to find out 10 g times minus 1 plus g of 1. So by putting value of g of minus 1 and g of 1, you will get 10 into minus 3 plus 3, which is equal to minus 27. So the correct answer for this question is minus 27.